Lesson 46 is continuing our study of circles and lines that intersect circles and the arcs and the angles that are formed. We are going to learn 3 new theorems in this section, 66, 67, and 68. Here's the first one. It says Theorem 66. The measure of the arcs in the interior of 2 parallel secant lines are equal. Go ahead and copy that down into your theorem section of your notebook. Here's what it's talking about. It says the measure of the arcs in the interior of 2 parallel secant lines. So here we have 2 parallel secant lines. The interior would be in between them, so not on this outside area, on the inside area right here. And it says the measure of the arcs in the interior, so AB would be one arc and CD would be another one, are equal. So the measure of AB is equal to the measure of CD. That's Theorem 66. We can use that in this example. It says AB is a diameter, AB is parallel to DC, and the measure of AD equals 44. Find the measure of DC. So our goal is to find this measure right here. While using Theorem 66, we know that AD and BC have to be equal because we have 2 parallel secant lines. So BC, measure of BC has to equal 44. So that's this section right here. 44. So we have both of these equal 44. We don't have this section over here and we don't have this section over here. But the piece of information we haven't used yet is that AB is a diameter. So if AB is a diameter, what does that mean? That this whole half of the circle, what's the measure of that arc? If you said 180, you'd be correct. So the measure of AB all the way around has to be 180. To find DC right here, we would take the whole arc, 180, and subtract out AD and BC, and we'll be left with just DC down here. So if we take 180 and we subtract out 44 and 44, then we'll get our answer, and you should get 92 degrees. And that's example 1. Theorem 67 says, in a quadrilateral inscribed in a circle, the opposite angles are supplementary. So when we have a quadrilateral inside of a circle, opposite angles in the quadrilateral are supplementary. Go ahead and copy that theorem down, pause the video, and then we're going to use it in example 2. It says ABCD is inscribed in the circle. So over here we have our quadrilateral, 4 sides inside the circle. Find the angles A and C. And what it gives us is A is 4 times x plus 21, and C is x squared. So we got to use our theorem. It says, in a quadrilateral inscribed in a circle, the opposite angles are supplementary. So we know that A plus C has to equal 180. So we're going to say 4 times x plus 21 plus x squared equals 180. Opposite angles are supplementary. So we'll distribute this 4. 4 times x will be 4x. 4 times 21 will be 84 plus 84 plus x squared equals 180. Then we need to move that 180 to the other side, subtract it, and I'm going to put this in descending order. So x squared will go first, subtract 180. 4x will go next. When we subtract 180 over, we'll get minus 96 equals 0. And then we see if we can factor it. So think of a multiplication problem that'll equal negative 96. We know we're going to have something positive and something negative. And then when you add it together, it gets 4. What you should get are 12 and 8. So we need positive 4, so we'll have plus 12 minus 8. And then you solve for your x. So x plus 12 equals 0, x minus 8 equals 0. So x is going to equal negative 12, and x is going to equal 8. Now we need to make sure that both of those work because they want the actual angles A and C. So let's use x equals negative 12. So if x equals negative 12, then so 4x equals negative 12. A would equal 4 times negative 12 plus 21. So that would be negative 12 plus 21 would be 9 times 4 would be 36. And then C would equal negative 12 squared, which would be 144 degrees. And then for x equals 8, A would be 8 plus 21, so 29 times 4, which I think comes out to be 116. And then C, x squared, 8 squared, you'll get 64 degrees. So your answer is all of those answers right there. That's example 2. Then, next theorem, it says, Theorem 68. The angle formed by two tangent segments is supplementary to the minor arc inside of the angle. So look right here at this diagram. It says, angle formed by two tangent segments. So we have our tangent segments right here. They only touch the circle in one place. And here's the angle that is formed by them, angle A. It's supplementary to the minor arc inside of the angle. Remember, minor arc is less than 180. So this arc right here is your minor arc, BC. This angle and this arc are supplementary, so they should add up to 180 degrees. So that's what this would say. Angle A plus the measure of BC equals 180. That's the rule from Theorem 68. Make sure you copy Theorem 68 into your theorem section as well. It's the last one for this section. The last example, example 3, is using Theorem 68. It says find the measure of BC. So we have two tangent segments here, and the angle between them is 30. And we know that BC and 30 have to be supplementary. So you would say 30 plus BC equals 180. So this one's easy enough. BC should equal 150, and that's the answer.